For question 6, this question is about iron and iron compounds. Iron reacts with chlorine to form iron 3 chloride or Fe2Cl6. Fe2Cl6 is like its molecular formula. Now balance the chemical equation of this reaction. So this is quite simple. So if you take a look now, when we say balancing the chemical equation, we need to ensure that the number of elements, the number of atoms, I should say, in the reactant side is equal to the number of atoms in the product side. So we call the elements that are actually on the left side of the arrow as reactants, and this one are the products. Once again, we read the arrow as like produces something. Okay, now if you take a look at the number of iron on the right side, it's 2. So pretty much I will write 2 here. So iron is now equal to 2, while chlorine is 6, so definitely, and here there are 2, 6 divided by 2 is 3, so to make it balance I'll write 3 there. And I think pretty much that's how to simply balance already the chemical equation. So there are 2 iron, there are 6 chlorine on both sides of the equation, and that's how to answer it. Total of 2 marks. Alright, now for letter B, the structure of an ion is shown. So we have an iron in the middle, and then Cn, cyanide. Okay. So deduce the molecular formula of this ion to show the number of iron, carbon, and nitrogen atoms. Now, looking at the formula, we have Fe at the center. Okay. Then how many carbons do we have here? 1, 2, 3, 4, 5, 6. So we can have C6. Okay, C6. And then 6 nitrogen as well, and 4. Now there's a charge of 4 negative, so we can write here 4 minus. Okay, we can write it down also as we can write it down in this manner as well. So wait, because it's like they have both Cn, I can write it down as FeCN6, alright, with a charge of 4 negative. Now any of these 2 answers are actually is acceptable. The molecular formula, so since the word molecular formula is mentioned here already, let me also discuss here what molecular formula is. Molecular formula is the actual number of atoms of each element in a substance. So in the way we have solved it, we identified the elements present, which is the iron, carbon, and nitrogen. And yeah, we need to count the number of atoms for each one. And we must show brackets in a charge, like the diagrams does score the mark. Okay, I repeat, you must show the brackets and a charge like the diagram to score, or like the diagram does to score the mark. Okay, so there's a bracket there, so same thing. Okay, now for 6C, this question is about chlorine. Alright, and compounds of chlorine. So we have chlorine reacts with warm turpentine, C10H16. Now balance the chemical equation for this reaction. Okay, so we have C10H. So we have 10 atoms of carbon here. I'll just write 10 here. And for each Cl, so we have carbon is 10, Hydrogen is 16. And then, wait for a while. And then we have chlorine is actually 16. Okay, 8 times 2 is 16. So in here, there, it's simple. So we have 8H16, Cl16. So we'll just write 16 here. Okay, so C10H16. So we have 1016. And I think that will give you 2 marks already. Now for letter D, okay, this is found in our textbook topic 6.1. Calculation of mass of substances. In this question, the equation shows the effect of heat on anhydrous zinc sulfate. So we have the chemical equation. So zinc sulfate, with the presence of heat, disintegrates to zinc oxide and sulfide. Now, when 12.6 grams of anhydrous zinc sulfate is heated, the mass of zinc oxide formed is 6.34 grams. The question is, calculate the mass of zinc oxide. Calculate the mass of zinc oxide formed when 63.0 grams of anhydrous zinc sulfate is heated. Okay. Now looking at the given, so we have 63 grams of anhydrous zinc sulfate, and that's the unknown, that's the form thing, and when we heat 12.6 grams of anhydrous zinc sulfate is heated. Now if we divide this, okay, we divide 63.0 grams divided by 12.6, okay, we'll get, this is around 5. So we can say that 63 grams is 5 times more than 12.6. And since it says here, the question is, when 12.6 grams of anhydrous zinc sulfate is heated, the mass of zinc oxide formed is 6.34. So since we know that it's 5 times, so 6.34, alright, 6.34 times 5, we'll get 31.7 grams. So 31.7 grams of zinc oxide is needed, or the mass of zinc oxide. Okay, so we can write here 31.7 grams. Again, don't forget units. Okay, that's for letter D. And then for letter E, complete the table to calculate the relative formula mass of anhydrous zinc sulfate. Use your periodic table to help you. Alright, so zinc, the number of atoms in zinc sulfate is 1. Sulfur is 1. Oxygen is 4. Alright, so what's the relative atomic mass? So zinc is number 65, and 65. That's right. Sulfur is 32. So again, I'm looking at my periodic table right now to answer this. Now for oxygen, it's actually 16. Alright. Now to count, so 1 times 65, so we have 65. 1 times 32 is equal to 32. And 4 times 16, we get 64. Now the relative formula mass is just adding all of this, so we'll get 65 plus 32 plus 64. That gives us 1. Okay, 1 and 16. So 161. So 161 is its relative formula mass. Okay, and that's it. That's for the review I gave you, and hopefully these videos will be able to help you in preparing for the upcoming semester exam. We'll see if I can still do more questions actually.